Hello, everyone. Thank you for joining us today. We are just waiting a couple of minutes more and we are going to start, okay? Okay, so thank you again for all to join us today. Our webinar is From Data to Decision Making, leveraging overall controller effectiveness to drive digital transformation. My name is Vera. I'm from Control Station, worked in marketing, and I'm based in Ireland. And before we start, just to let you know that anytime you want, just feel free to leave your questions and comments here in the control panel. Our presenters today are Dr. Bob Rice and George Buckby. Bob Rice has nearly 3 decades of engineering and product management experience in process industries. As a recognized thought leader, Bob oversees development of Control Station's award-winning suite of process diagnostic and optimizations technologies, including the Plant ESP control loop performance monitoring solution. And George Buckby brings extensive experience in the automations and process industry. He is a PE and an ISA fellow. George previously served as a general manager of Expertune, and he's currently the president of Sage Feedback. For who are new to Control Stations, we've been an active innovator since the 80s. Today, we are proud to support an increasingly global clientele, and our customers include leading manufacturers from across the process industries.
Good morning or good afternoon, everyone, depending on where you are. This is George Buckby, and happy to introduce today's webinar agenda. We're going to be talking about OCE, or Overall Controller Effectiveness, and walking you through from the beginnings, kind of what is it, what do we mean, how do we calculate it, and then moving on into what can you do with it, how do you work with this metric, what does it tell you, and who should be looking at that. And then getting into some very specifics about exactly how to use that in conjunction with Plant ESP and how you can get started with using OCE to effectively improve the performance of your controllers and in doing so, also, of course, the performance of your plant. So welcome to the webinar, and we'll be following roughly this agenda as we go along. Before we get started, we're going to do a quick survey question, and you should see the survey popping up on your screen, and please take a minute to respond and tell us a little bit about how you currently measure control performance. Bob and I have been working in this field for a long time, each of us, and have seen quite a variety of approaches to working with control performance, all the way from we don't do anything up to we've got a really fully complete way of looking at what's going on with controllers in our plant. So be curious to hear your input and feedback on what you're currently doing.
Yeah, I mean, it's you know, over the last 20 years, we've definitely seen an increase in the amount of tools and tracking mechanisms in place. You know, 20, 30 years ago, it was purely reactive, right? You waited for that call, that inevitable call from the operator to come in that something is broke, and you reacted. There's definitely been an increase in the amount of tools that are out there for tracking things, and you know, it's also what kind of things are you tracking, right? Things have gotten a lot more sophisticated over time. to be able to, track things other than, hey, it's running or it's not in auto, or is it not in auto, right? And those advanced analytics, are sitting on top of more advanced data historians and trending package and more advanced DCSs, right?
That's right. Even in those early days, a lot of it was just kind of manually auditing or walking through the plant and seeing what's there on some kind of routine basis. So things have changed quite a lot, as it has in all the rest of our lives, with everything being automated and fed to us as kind of curated information.
Yeah, and it's becoming far less common to find sites that don't do anything at all, because those are the ones that are, there's a lot of opportunity here, right? And what tools, what metrics, what answers do you provide?
Right. So
I think that's probably enough time there. If we want to look at some of the results there, Vera, right? So that's not necessarily a huge surprise, right? The lack of tools, it is what it is, right? Purely reactive, some in-house tools, some third-party tools, some structured, but that's, 2/3 of the group don't do anything, right? That's a great audience for us, right, George? Lots of opportunity.
Absolutely. I mean, I think the biggest problem with control performance is first even knowing whether or not you have an issue. And if you don't have any kind of approach, you probably don't even know whether or not you have an issue in your plant. And so that is a good place to start for us to understand, how would you go about making improvements? Why would you even know if you needed any improvements if you don't know where your controller performance is? So that's a really good launching point for us to start.
Yeah. I mean, you definitely can't control what you can't measure, right? So how do we measure controller performance?
Right. And interestingly, there's a smattering of others in here as well. In-house tools. I've seen a lot of people try to build in-house tools, which is great for a little while, and then becomes very difficult to sustain as maybe the person that developed the tools moved on to a new role, those kind of things. Definitely using more advanced solutions like third-party software, like Plant ESP, or having structured metrics that are fed into the daily decision-making process is something we'll talk about as we go on in this webinar to get you more insight into how this can really help drive your day-to-day improvement in the plant.
Excellent.
So, good. Well, let's go on here. And good. Okay. So we're going to start talking about OCE, or overall controller effectiveness, in the context of a much older metric that's been around, really invented kind of in the 60s and then rolled out in a big way as part of TPM, or total productive maintenance, in the 80s. This idea of overall equipment effectiveness, which was an idea to say, how can I tell if a particular machine or even a process is doing the best that it can do, by looking at things like, is the machine or the process even running? Is it working? And then is it performing up to its level of capability, production rate, for example? And is it producing product that is of satisfactory quality? And using that combination of information as a way to say, is the piece of equipment or group of equipment in the form of a process delivering what it should be delivering to the plant? And how do we know where it stands? And likewise, this idea of overall controller effectiveness is kind of an analog to OEE. OCE will tell us, are the controllers individually or as a set of controllers delivering against their capability? So I'd like to encourage you, while we're presenting this slide here, to think about how might you calculate something like that to see if a controller is doing its job. Go ahead, Bob.
Yeah, exactly. And you do want to kind of think about that kind of analog to OEE, right? And when you're talking about PID controllers or controller performance, you kind of have that same idea on trying to think about availability and performance and quality, and what are the attributes about a PID controller that are that would give you that same bit of information, right? How available is the controller available to do its job? What is the performance? Is it having the right quality? Because OEE is that kind of percentage of time that that piece of equipment is truly productive, right? And we want to try to come up with an analog on the controller. What is the percentage of time that PID controller is truly productive, that is doing its job to its full potential without any issues or anything associated with that? So try to come up with an analog there. And what me and George are going to talk about in this presentation is how we can do that, right? What are some of the different attributes and ideas that we can apply to controller performance to come up with a kind of a singular normalized style metric that is easily explained and easily defended to the crew that you may have to explain this to.
Right. So let's see on the next slide here. Oh, go ahead, Bob.
Yeah, and so when we think about that idea of looking at availability, performance, and quality, there are attributes about PID control that kind of fall into those buckets quite cleanly, right? And the first one is the one everyone looks at, right? What's the percentage of time that you're in automatic, or you're in cascade, you're in the appropriate normal control operating control regime for that system? What is the percentage of time that you're in that, right? And then look at what is the percentage of time the controller is free to move. Not just that it's at 0 or 100%, but it's free of moving within those constraints, right? Because we all know the game operators play. They don't like it swinging. So instead of tuning, they just move those controller limits. So it's really tight. It's just bouncing between 45 and 50%. That's a limit, right? The controller's not free to operate. And so let's think about the time the controller is free to move, right? And then let's think about quality, right? How do we measure quality of a control loop? How well is it operating within a band, right? Is it close to set point? Is it far away? Is it over tuned? How well is it? What is its behavior? How good of control are you actually experiencing? And just like OEE, you multiply those three things together and you get a very sensitive metric. I mean, that's kind of the terrifying thing about OEE. It only takes one of those numbers being 0 before your number plummets, right? And so it's a very sensitive metric, and it's one that will dive quickly, but also one that you can recover from a performance standpoint quickly. And this overall controller effectiveness is kind of I think a useful analog for relating it back to OEE. Right?
And I think the combination is really one of the other things I really like about OCE as a measure is that it's, in the end, pretty simple. Like, you don't need to have a PhD in automation and control to understand how this works. This is something that every operator, every manager in a plant, everybody that's working there can grasp and understand. And even those that are not necessarily in automation per se, or control engineers or technicians per se, can understand this and why it's important. That's another reason, and we'll get to that a bit later about which people use this tool, but it's nice that it's simple, easy to explain, and effective at conveying this idea that, hey, we want our controllers to be able to do their job.
Yeah, it really is about being able to communicate a value, communicate a metric, not just to yourself, the control engineers that are out there, but to the wider team. And keeping things simple, keeping things easy allows that communication to be a lot easier to try to explain.
Right.
So go to the next slide. So no presentation is complete without an example, right? To kind of show what does OCE look like in practice when you calculate it. And this was an example from a level controller, and we all know how much fun level controllers are to tune. But it kind of brings an interesting aspect that if you were to look at the process data, which is that lower set of trends, and you're an operator and all you're looking at is the process variable and the set point, how well you're tracking, you may be giving yourself a positive check mark. It's doing its job, right? It's running exactly as it's supposed to. And hey, it's in automatic 100% of the time, so we must be doing well, right? But when you start to actually look at the availability, right, and the quality of it, right, we're constrained. That poor level controller is so aggressively tuned, we're slamming and we're operating right near that lower limit all the time, which means that we're constraining that controller. It's not able to do its job, and that's something that we need to be aware of, right? We also need to understand that the average error, how much variability we have in the loop, is actually not perfect, right? It's not terrible. We're spending most of the time in control, about 63% of the time in control, right? But there's a significant time period where we're not running in control, and an in control can look at a couple of different things. We're talking about the quality side of it is we're tracking within a certain tolerance around set point, and the output travel or the valve movement is within acceptable norms, right? And so you may say like, okay, well, I've got 100% of the time in normal, 63% of the time in control, 40% of the time unconstrained. If you were to just take the average, you wouldn't get a good picture, right? By multiplying them together, kind of similar to the way that OEE does, you get that OCE drop, and now you can immediately get a red flag that says, hey, my OCE is 25%, it's not doing its job. So really, out of all the time that's there, 25% of the time, do all the attributes actually show positivity, right? They're not, it's good in all four of those areas, all three of those areas, 25% of the time. We are identified as a tuning issue. We made some tuning changes, and now we can see OCE went into 100%, and we were able to correct the issue. So OCE is an effective way of identifying opportunities that maybe the operator didn't see because they may be looking at one or two of the aspects of it, right? They may just be, am I in auto or am I not, right? And maybe if I'm close or if there's high variability, right? But they may not be looking at it.
This red light that pops on and says, hey, you should pay attention over here.
Yeah.
Or sometimes I like to think of OCE as kind of like the, how do you feel when you go to the doctor? It's not telling you your blood pressure or your heart rate or anything like that. But if you feel bad, you're not feeling well, it's time to go see the doctor. And OCE in some ways is that signal that's saying, hey, this controller doesn't feel well right now.
Mm-hmm. Yeah. So, George, what can like OCE tell us, right? What are some of the things that OCE can reveal to us?
Let's take a look on the next slide, and we'll dive into that a little bit. Many different things can cause OCE to start dropping. So if the instrument fails, if the valve is the wrong size, if the operator left something in manual, I mean, this is a very common thing. When any part of the controller is not working properly, what do operators do? They stop trusting it, they put it in manual, and maybe it does, maybe it doesn't get put back into automatic or cascade sometime later when somebody might notice it. Sometimes it might stay there for days or weeks in manual. If you've got a lot of noise, if the tuning's not working, if it's not working in certain modes, if you've got an issue, as Bob mentioned before, where somebody set artificial limits on the outputs, if for any reason the controller is failing to do its job, OCE will tell us. OCE is a great indicator to tell us that no matter the cause, no matter the fundamental issue that's underneath, this controller is now failing to do its job. Now, it's not necessarily going to give you the specific diagnostic. It's not going to tell you, oh, OCE is low, and therefore you should go do some maintenance on this valve. It's not going to get that specific. We're going to talk a bit later about how to transition from the OCE red flag into the diagnostics. But what it's telling us is there's something wrong here and you need to pay attention. Like I said, it's like going to the doctor. You don't go to the doctor every day of the week. You go when you're not feeling right. And OCE is that red flag saying, hey, things are not right. It's time to go take a look. It's time to go pay attention to what's going on here.
That's right. It's like that check engine light, right, in your car. That engine light pops on, and it could be any number of things, but it's important to go and take a look at it.
Take a look. And it's important to do that, like, as an individual controller. And then also when we look at OCE in aggregate, if we say, what's the average OCE for the 100 loops in this part of the plant, that's also telling us something about whether that whole part of the plant is being in good control or not. So whether you're in an oil refinery, a paper mill, or a mine, or wherever you happen to be, this is going to tell us something about that. And it's important because this is this is worth a lot of money. You know, if you think about how much the controllers cost in your plant, you know, the instrument, the valve, the wiring, the DCS or PLC, the programming, the diagrams, the documentation, you've probably invested anywhere from $10,000 to $50,000, even $100,000 in each control loop, mostly depending on the size of the valve. But that's a lot of money to pay to have something not do its job. But you wouldn't pay $50,000 for a car and have it sit in the parking lot and never drive, right? But that's what happens if you leave a loop in manual, right? It's like paying for the car and then leaving it in the parking lot and never driving it. So the value you can get from getting these loops back in order is really important to increase your return on assets and to make sure that those controllers are going to actually deliver the value to the plant that they were supposed to. They were put there for a reason. And OCE helps point out which ones are basically not doing their job.
Yeah, and it's that kind of normalized aspect that George had mentioned earlier that allows you to roll that information up. It's not, just one loop. You can aggregate it. So it's, hey, in this area, what is the average performance? What about the entire plant? And now you can start to say, okay, well, what about plant to plant? Are there plants that have higher performance? And when you start to aggregate and start to normalize metrics, it gives you a lot easier way of tracking and maintaining that performance. And it gives you easier ways to do regular reviews with operations and management with those single numbers, by providing that kind of relatable, easy to understand number for everyone. And it does help you prioritize and identify those opportunities.
Great. I think we can go on to the next slide here.
Yeah, and so that kind of takes us to that idea is, OCE is that what has changed idea, right? It's the idea of having kind of a singular metric that allows you to identify changes in performance, right? It needs to be, for that metric to work, it needs to be easy to explain, easy to track, and linked to meaningful results, right? So by having that normalized number, it allows you to use it as almost as change management, right? What has changed, and be able to manage those changes and track it. And these types of metrics, they're found in a lot of different industries, right? You've got your credit score, whether everyone likes them or not, they are a normalized score that tracks your credit worthiness, right? Based on any number of unknown KPIs and metrics, and some of that is kind of debatable, right? But in customer service, right? How do you track how well a customer works, how well a customer is loyal, or how likely are they recommend a product? They have net promoter scores, probably something you've never heard of, but if you run surveys and run stuff, they track net promoter score, and it's a single number. You have these kind of singular KPIs because it allows you to be able to take that single number and start to correlate it with things like production metrics and goods sold and production rate. And now you can start to say, okay, how does OCE track to those other things? And that allows you to prioritize things, right? Prioritizing actions is what keeps us sane, because if we were to go look at a plant and you go look at the OCE across 2,000 loops, you may have, let's be honest, 300 red lights blinking at you, right? And you can't fix 300, but how do you prioritize, right? Well, you look at importance, you look at the cost of that loop, the value of that particular asset, and you start rolling that kind of to help you prioritize. It helps
Right.
you do diagnostics.
OCE, a loop, Bob, that has always run at 100% OCE and it's suddenly down at 0 or 20 or something like that, hey, wait a minute, something's wrong here, something has changed. It kind of draws your attention right into that. That's, like you said, the prioritization is really critical. You don't have time. You have 2,000 loops in your plant. You simply don't have time to look at all 2,000 loops every day, let alone take any action to improve them.
That's right.
So,
that's right. Being able to prioritize, to find those things that change.
Right.
And it drives you into those conversations, right, George? Is having regular reviews of process control, which is a metric, but it's also a change in culture, right? To have a culture of continuous improvement in optimization and have those reviews and have those KPIs, that That is what generates success in any loop monitoring project, is having those regular reviews and having KPIs that are easy to communicate. You're not spending half the meeting explaining what these metrics mean. It's the meaning is understood.
That's right. On the next slide, we actually talk a little bit about that and how this information can be used. Again, most of us, if you're in this webinar, you probably come from an automation and control kind of background, or on more the technical side of things going on. And so you're probably at this point pretty comfortable with what we're saying about, okay, OCE, I can see what it is, how I use it, how it might help me diagnose a particular control loop or instrument, or, trying to drive me to a problem. But I think it's really important for this cultural change to happen, as you've all heard in, kind of probably any kind of discussion about, digitalization or digital transformation in a culture. You've got to inform people that are kind of outside of that normal day-to-day dealing with instrumentation. You want to get your process engineers and operators and operations management educated about OCE, so that automation and control is more than the black box that a lot of people can treat it as. OCE is a pretty straightforward metric. If you train people that, hey, this just tells you, is the controller doing its job or not? People can latch onto that, and I've seen, all the way on up to, plant level, site level management using tools like this to be able to have a handle on how well are their automation systems working. It's, like Bob said, in aggregate, you can look at OCE across 100 loops or 1,000 loops, and it's going to tell you something about whether things are getting better or getting worse, whether something has suddenly changed, and where you stand relative to your peers. If your company has 3 or 4 or 5 or 10 similar plants, comparing OCE numbers across those plants tells you something about that. If you have operators looking at OCE and understanding that what they do on a day-to-day basis, what actions they take, putting a loop in manual, opening up the valve 100%, and then forgetting about it when they go home from their shift, has an impact, a measurable impact on a performance metric for the plant. It helps open up a different kind of conversation, so that you can start working with, instead of it being a one-off where you got to go tell an operator, hey, you should be putting this loop back into automatic. We can talk about it from the higher level of looking at the OCEs for the overall operation, and having them understand that, this helps drive the overall performance of the plant. And if you don't believe that, I'll ask the question like, how well would your plant be if 100% of the loops were in manual, right? Or if all the valves were fully open or fully closed, right? It would not be running very well. We have those controls there for a reason, and this metric helps people to get into the context of why controls and control performance is important. They don't need to know all the details about oscillation factors and tuning factors and overshoot, and they don't need to know all those details to know that the controls are important and there's a way to measure whether or not the controls are doing their job.
Yeah, everybody on this list is invested in making sure that all the control loops are doing their job, because if they're doing their jobs become easy. The process engineers can do the optimization work. The operations can make sure demand and production rates are met. Operators aren't spending all of their time manually adjusting everything to make sure the plant is behaving well. They can, be more focused on making sure everything is safe and sustainable. And, that's why everybody's invested in this, right? We want to make sure loops are behaving well. And you need a common language that you can use that defines that, right? Having a singular metric, as one that's normalized and simple, is really key. So it comes down to is how do you use this as a management tool? And there are a lot of different ways you can actually kind of take a look at this. But again, it's a singular number, right? 0 to 100%. Everyone understands 0 to 100%. We all went to school at some point, right? 100% is good, 0% is bad. So you immediately have a kind of a common language. You don't have to explain, oscillation factors or variability coefficients and normalized variation, all this stuff. It's very simple. And when you start having a singular number, that number allows you to relate back to things that are maybe more dollars and cents related, right? You could correlate OCE as a metric to production rates, a lot the same way that, again, you use OEE to relate back to production numbers. You can start to understand that, oh, when OEE increases by a certain amount on this machine, we gain X number of widgets per hour, increased production, or our quality improvements, or our dollars, whatever these things are. It allows you to kind of go back to it. And so using this as a management tool to track not only individual, but to aggregate that information up to units and areas and plants and regions and divisions, and start doing site-to-site comparisons. And I've seen results where when you look at OCE across an entire fleet, you can immediately see the doers and the ones that need a little more effort, right? That OCE can be in the 80-90% range for some sites and be at 20% for others. Well, let's put some effort down there and at the 20%ers and get them up. It becomes easier to explain, easier to track, and again, it's a singular number. That normalized metric cannot be, can't talk enough about it. It's easier to explain that than other metrics, and trust me, me and George have been doing this for long enough that we're probably sick of explaining some metrics to customers, right? Let's keep it simple, right?
Before we move on to the next poll question, Bob, just one comment here. When we talk about it as a management tool, we're not necessarily talking about this as only for managers. I mean, I think this is a tool that helps all of us manage our work. So whether you're an instrument technician, an operator, controls engineer, or a process engineer, whatever role you have in the plant, this is a tool to help you manage your work. And by manage your work, we mean those kind of things: set priorities, understand what's going on, help drive actions, help focus our attention. It's a tool across all of those different roles. So why don't we move on to our next survey question here, polling question, which is, how does the operating team currently evaluate control performance? What do the operators do? What does operations management do when there are control performance issues? And you can select on this one multiple answers here. You don't have to select just one. You can select several of them if they apply in your plant.
Yeah, it's, and this is a tricky question because you probably may not have even thought about, how do we evaluate control? How do we react to things? There's always the problem child loops that everyone's attention is always focused, but that may be only 10 or 20% of the loops that you have. And understanding the impact of those controls and having good communication, how do you determine and prioritize what controllers have issues, right? Or where you should be focusing your attention.
Yeah, I've been in some plants where, the answer to control performance is the operator says, it's broke.
Mm-hmm.
What's broke? Right. Well,
yeah.
The controls aren't working. Okay, well, let's get more specific. Again, this is a way to get some more specific metrics and tools and measures that will tell us what's broke, right? What's broken in the plant, and help get us on the right track.
Yeah, and that, how do you evaluate controller performance over time? It's how many times has the operator called you this week compared to last week? Well, I only got 2 calls this week, so things must be working a lot better, right? That's one way of quantitatively measuring it, but probably not all that consistent, right? Yeah, so being able to have that routine method. Do you have a process? You go and evaluate and review and you track and you maintain. What does that process look like? So I think that's probably enough time for the survey. If we want to take a look at the results real quick. Yeah.
Right.
Not a surprise, right? I'm looking at the problem and I'm asking if there is a problem, right? That's probably the most common. Right, you focus on where the issues lie. I'm glad number 2 was not that you have no idea what the impact of the controls have.
Yeah, I think that's really good. Yeah, it shows at least people understand there's value there and understanding that the controls are working right. I'm pleasantly surprised at the last item there that folks that have a routine method to review and track control performance, because that is one of the keys to using OCE to make improvements in your plant is starting to think about bringing that in to the daily and weekly decision-making activities that go on in the plant. So that's encouraging to see 38% say there's some routine method. Now that can be as simple as, you know, reviewing the operator logs at the morning meeting and saying, oh, there's a problem with XYZ temperature controller.
Mm-hmm.
You know, that can be a good start.
Excellent. So I guess the question is, well, how in the world do you calculate how do you calculate OCE, right? So within Plant ESP, we calculate these metrics, right? We calculate time in normal, time not saturated, time in control, and Plant ESP can grab all of this data analysis, and we've got services and tools to help you decipher it with our system health monitoring, DLS style services, digital life cycle services, where we can help prioritize and identify those opportunities to help drive that kind of usage, drive those weekly or monthly meetings to make sure you're focusing on the priority loops. And what's nice is this leverages all the data you already have, right? You've got plant historians. Everyone here has most likely invested a significant amount in their data historians, and more data gets thrown in those historians, right? Let's generate some value out of that data, right? Let's look at that process data output, mode, all of that information, and we can start having dashboards to identify those opportunities, roll that information up into normalized metrics. And we have the software programs, but we also have the service programs to help you to use it, because just software alone is never the answer, right? You need to have a program in place, whether internally or externally, to use that information, right? Who is looking at the reports, who's actively pursuing the opportunities to go and make those corrective actions. And we've got the tools and services here at Control Station to ensure that those opportunities are discovered and maintained and tracked, right?
That's right, and also I think we're starting to allude to it here on the bottom of the screen is, you know, once you have OCE in place and get started pointing in the right direction, to have the tools to dive deeper and start doing the diagnostics on that particular loop to say, okay, and here's the reason why OCE has dropped on this loop. That's a really important, you know, step forward. So we have OCE, it points us in the right direction, and now diving in with Plant ESP, I think of it like the, you know, the Star Trek tricorder or whatever, puts, you know, or going to the doctor's office and getting a workup done, and they tell you, okay, well, your EKG is good, but your blood pressure's high, and this, you know, your blood work says this or that with your chemistry. Here's what the issue is. Here's what we need to do for you. You know, take you to the next step. That Plant ESP is kind of driving that out once you have OCE pointing you to the right direction.
That's right. That's right. And again, you can, you know, everyone in control seems to love their car analogies, right? It's that check engine light, right? When you get a check engine light, you got to hook that device up, and it gives you the output of that check engine. Okay, it's this sensor. This is wrong. This is, you know, it gives you that kind of action list, and that's really where the Plant ESP tool does those diagnostics, those analytics, and those trends to help you identify root causes, identify the opportunities in detail, versus OCE, which is where does the problem actually, where is the problem?
I take that analogy even farther, Bob, and say that, you know, the plants that folks are working in are much more complicated than the cars, right? Each individual loop might be, okay, roughly the equivalent of thinking about your car, but you're actually flying a 747 every day if you're operating one of these plants. And I don't know about you, but if I go to the airport and get on a plane, I sure as heck hope that the pilot of that airplane knows about the overall control effectiveness of every single thing on that plane. I sure hope that they know what's working today and what's not. And, you know, and they do. They have, you know, they track all the issues and know where they are and know the diagnostics and the follow-ups to go through with each one of those. And, you know, operating an oil refinery, a pulp mill, you know, a chemical plant is just as complex as operating a 747. And you would hope that people have access to the same level of information and take the same interest in making sure the plant is operating up to its best capability.
Yeah, absolutely, absolutely. And so, you know, when we talk about how Plant ESP kind of helps you streamline this process, really what it's designed to do is to help you have those tools for a consistent analysis. We're getting the data in a consistent fashion. We have dashboards, we've got services 24/7 view to be able to help you identify where those opportunities are, provide the priorities and diagnostics and the actions to make sure that you follow through with the process. And you know, just from a streamlined standpoint, all of this information, while it lives in the Plant ESP silo, there are connectors into the silo that you can consume this data and display it in other places, because all of our plants are interconnected with Power BI dashboards or TrendMiner or Tableau and Excel. Everyone has, you know, all these reporting engines, all of the data that's available here. While we've got our own dashboards and capabilities, we've got a completely open REST API that other tools can actually consume our data. So much like your data historians got tools that allow other tools to extract the data out of the historian to generate more value, all of these KPIs also have the ability, again, to generate more value out of the data that you're calculating. It's not an individual island of information. You can get a lot of details this way, and we can have dashboards that track OCE and percent time and normal, as well as, you know, Plant ESP dashboards that dive into the individual diagnostics and root cause analysis and looking at interaction analysis across 1,000 loops to identify where all the priorities and where the oscillations originate, because it's those diagnostics that are key, right? You got to be able to find that root cause, and Plant ESP makes it easy. I think that
integration, Bob, is so important because you know, we don't expect you to go like create a whole new process for dealing with OCE, right? You don't need to have an OCE meeting every day. You don't need to have, you know, a separate OCE planning session. The whole point of the integration and bringing that data in is that you can feed that into the ways that you already make decisions at your plant. If you have a daily morning meeting about the health of the plant or the process, that's the place to bring OCE. If you have a weekly maintenance shutdown planning session, that's the place to bring the OCE information and the valves, related valve information and instrument information. This gives you some tools to automatically, through integration with Tableau or Power BI or whatever it is you use at your plant, to feed the correct information into those meetings or structures that already exist to make the decisions, right? So this is not about, oh, let's go create a whole bunch more work. This is about, let's get the right information to the place where people are already planning the work.
Yeah, absolutely. And you know, the thing about, you know, loop analytics and loop monitoring and all these tools that, you know, I heard a customer say this once, and I love it. All these tools lower the cost of curiosity, right? You need to go and investigate. You're curious what's causing these problems. If you don't have the tools, you could spend days staring at trends versus very quickly get to the right answer. It allows you to go after more problems, solve problems more effectively. You're just a more effective engineer, right? And a lot of opportunities. What are some of the next steps or the things that customers can do to get started, to take a look at this?
Sure. I mean, I think if you're in this webinar and you're thinking, oh boy, this sounds like a lot. I got to do the software and the services and all of this stuff to kind of get going. The shorter answer is no, you don't. I mean, you can get started right away by understanding how big is the opportunity at your plant. I mean, if you don't already know what percentage of your loops, let's say, are running in manual today, I would say, hey, take a notepad or take your phone out to the control room if you can have it there, and just do a quick survey. Look at 20 loops. Pick them randomly. Don't pick the 20 most important loops of your plant. Just go out there, flip through some screens on the DCS or whatever HMI you have, and look at how many loops are running in manual. If you find out that, hey, I looked at 20 loops and there was only one in manual, that's great. I mean, you're starting at a really high level, but most likely you're going to find that you have quite a few that are running in manual, or if they're supposed to be in Cascade, they're maybe only running in auto. but do a quick survey. That tells you how big is the opportunity at your plant. I've seen everything from 5% to 90% running in manual. I mean, it really varies a lot by industry, it varies a lot by geography, but get an idea where to start from. And then start thinking about using that information to justify the next steps forward. Get some automated tools to be able to collect and gather the information, right? Controlled performance monitoring. I like the way that Bob put that, helps you to lowers the cost of curiosity because it will automatically start giving you answers to questions that you have without requiring you to take days and weeks to go investigate each one. And then, of course, moving on into training, educate people about OCE, educate people that you have ways to look at controllers and tell what's really going wrong. And then, as the last step in that, starting to integrate that information into your plant environment, into your culture, and make that happen on a routine, kind of no-brainer. Every day we're going to talk about OCE in kind of basis, so that it kind of gets that into the culture. So those kind of 4 major steps there in the process, but you can start that first one today. Like I said, that'll take you half an hour of your time. Go take a look at what's going on in your plant, understand how big is the issue.
Yeah, that's really a good place to start is, what is your opportunity? And I can't say enough about the bottom 2, the training and the integration into your team. The biggest hurdle of maintaining any tool that you have is changing that culture of continuous improvement, making sure people are trained and understand how to use the tool, but it's part of that weekly, daily stand-up meeting, even if it's a 10-minute conversation of, okay, what's changed since yesterday? Let's go and prioritize it. If you use the tools, you will generate value. And to use the tools, you have to integrate that into the process and the workflows that you have out there. Absolutely.
Okay, I think we have one more survey question before we open up for a Q&A. So let's take a look at this one. This is just about what you would like coming out of this webinar. What would you like to have in terms of getting more information? There's a lot of information available about OCE and some of the tools that we mentioned here. There's some future webinars coming up that you can opt in here to get more information about any or all of those. Or if you choose not to, you can choose none of the above and not have us track you down with that information. So please take a minute and fill that out.
Yeah, and I would definitely be interested in that position paper because I know, George, you worked put together a pretty good paper on OCE and its use cases and its background, and it's a really good article to help you understand the value of monitoring loops and OCE as a metric, right? There's a lot of interesting analogies and information in that report.
Yeah, give you a chance to do a deeper dive into OCE and get through that. So good. I think at this point, if you have questions, you can start typing them in on your GoToWebinar controls in the, I think it's either the questions or the chat area where you can enter questions.
Okay. If you want to go to the question slide there, Vera, that would be great. There we go. Just so you can see a picture of me from way long ago.
Yeah, so you can type the question in the control panel, and we have a couple of questions here. So let's start. What have you found by using OCE at customer sites?
That is a very loaded question. We've found a lot of problems, right? OCE is a very good way, again, of trying to identify where opportunities are. And what we have found is that by switching to something a little more normalized, we were able to identify problems and what, there's kind of 2 answers to this. We found the problems, right? There are a number of loops and opportunities that we've corrected. But as a general way, we found that by putting it in terms of OCE and tracking it, the engineer at the site was able to more easily share the performance changes and improvements with the operations team. And he, for years had always, talked about control loop performance. He was always very proactive, but he always struggled with, how do you actually explain to somebody how well the performance of the loops are doing? And now it's become part of their regime, where now the operations manager is, where is the OCE number? And every week that he's getting pestered, okay, where is it at? Is it getting better? Is it getting worse? And so we found that it engages more of the plant staff to see the benefit in monitoring performance. And so it helps spread the gospel, right, of this is what you can do with better performance, and now you've got a number that can track. It does open you up to criticism now, because now people are keeping an eye on things, but that's what you want. You want everybody to see the performance of those KPIs and metrics.
Yeah, I think one of the first things you get is this perspective that, like I said, if you're in an oil, let's say an oil refinery with 3,000 control loops, and you find out that 20% of them have an OCE of 0 or near 0, I mean, that should really get somebody's blood boiling, right? That should really get your attention and say, wait a minute. It's, like my analogy before of a control loop is, $10,000 to $50,000, or roughly the cost of a car. You'd say 20% with a low OCE means you've got 600 cars in the parking lot doing nothing, right? Any plant manager, refinery manager should be upset about that. Every control engineer should be upset about that. I mean, that's a huge number. It's a huge asset that's just not being used effectively. So yeah, the very first thing I think people usually find is just an awareness that, hey, wait a minute, this problem has been hidden. We never knew it was here. And there's a significant opportunity to improve the performance of the plant by getting those assets working effectively.
Mm-hmm. And you don't know what you're not measuring, right? If you're not measuring it, you've got your head in the sand, and you're missing out on the opportunities.
Right.
Thank you. We have other ones here. So how OCE applies to different control structures, such as overrides and MPCs?
That's a great question. And so where that impacts is a couple of places. One is obviously on the normal mode, right? What is the mode in which it is normal? So is it normally in remote set point for APC, MPC, right? You're going to incorporate that into the normal mode. The other thing that's really important about all KPIs and metrics in general is understanding when the KPI should be calculated and when they shouldn't be calculated. When you're in an override scheme, generally speaking, the controller is not in operation, right? And so you would actually not be calculating OCE if the loop's not actually in use. And so you would use enable conditions to turn calculations on and off, because you want to make sure when the loop is suddenly in the active position, then its performance is being calculated. So you have to use enable conditions to make sure that you're executing the calculations at the appropriate time. And you also want to make sure your modes are correct. And if your MPC is moving limits around, you've got a constraint controller that's moving the limits, that the OCE calculation is using those moving constraints as part of its calculation.
If you roll back a few slides, Vera, to the one showing Plant ESP in the middle of the slide, that kind of illustrates one more, I think. Mm-hmm. Yeah, here. I mean, this is the job of Plant ESP, right? In part, is to manage all that information and to keep track of which modes are normal and not normal, and do those kind of things so that you can generate a meaningful statistic for OCE coming out the other side of it. So its job is, through proper configuration and setup at when the system is installed, to be able to understand the different controller modes, and on a loop-by-loop basis to be able to say, well, this is normal. This is normal for this loop, so right, let's not worry about that. And these are the abnormal modes of operation, and that's when we do want to pay attention. So that's a really good point. Thanks for the question, because it is really important. It's not just about loops being in manual versus auto. In fact, for some loops, manual is the normal.
Yeah,
right? Let's not forget that. There are some controllers for which manual is the normal, and you don't want to be flagged to do anything about that loop. So it's important to have that depth of system configuration understanding built into the software that's monitoring your plant, so that you don't have to grind through that every time you see a loop in manual. It's already taken care of here. It's already taken care of in the software.
Yeah,
Thanks for
and that's why we refer to it as time in normal versus time in auto. As normal can be one thing, multiple things, and the logic behind what is normal could technically change as a function of time as well. So
one more here. So not all loops are created equal. Do you have a quantitative method for prioritizing loops based on the purpose of the loop, cost of the poor performance, and etc.?
yeah, and so that configuration again is kind of managed within ESP itself. Not all loops are created equal. There are importance factors that are assigned to loops that are customer assigned based off of either a criticality to production. It could be cost benefit. It could be that these loops are part of APC, so they can be assigned a different weighting factor to be able to give them the importance that they need. And so you can choose to use those when you're aggregating. So if you've got 20 different loops in a unit, when you aggregate the overall the OCE for that, you can either take a flat average or you can average it based off of a weighted average based off the importance of that. So when you're aggregating information, the more critical loops are going to have a heavier influence. Their OCEs are going to have a heavier influence on the piece of equipment that if you want. As well. So that information is managed and configured and stored within Plain ESP because that is important, right? But all loops are important. It wouldn't be a loop.
Let me add one thing to that. I mean, all loops are important, and definitely, you know, the key money loops that you think about in your plant definitely need to get more attention. But I'll add to that, they already are getting more attention because every operator and every controls engineer has already been told that, hey, you know, the boiler pressure is important. Yeah, we all know that, right? And they get a lot of attention. It's also critical that the other loops that impact those critical loops get attention. So I think it is really important. It's great to have things aggregated and prioritized according to, you know, the meaning of each individual loop. But one thing I've found very often is, yes, the critical loops get a lot of attention, but the loops that impact the critical loops maybe don't always get as much attention as they deserve. So that's a good thing to build into, again, the process and the configuration and the troubleshooting process is to peel that onion back one more layer and dig deeper into what's causing the issues.
Absolutely.
Maybe a topic for another webinar.
That's right.
Yeah.
That's right.
Does OCE address linear programming, scheduling among plant operations goals?
So OCE is a calculations that's, you know, processed across time. And if your plant changes production rates, if it changes product lines and product codes, you know, that you change what you're operating at your plant, there is the capability within Plant ESP to actually extract OCE on a particular loop based off of production type, right? So if you're running product A, B, C, and D on the same loop, if you feed that into ESP, you can actually extract out the OCE components based off of what is the OCE on this loop when I'm running product A versus product B. And so you can actually kind of expand those kind of state-based results with OCE as well. And again, that information is kind of the engine within ESP has all those capabilities, and those kind of feather out to the OCE calculations as well.
Okay, we are running out of time, so there is just one more here that we need to go through. So can you provide a little more detail on the last variable and in the OCE calculation, as it is little vague? Is it percent of time within alarm limits?
So the time and control is a metric that is kind of user defined, but it's a percentage of time that your process variable is within a certain constraint that you've assigned around set point. We use a metric called AAE, which is average absolute error. And what it's doing is it gets the limits get set based off of historical kind of golden batch data. And so when we commission the system and we look historically back through, we use the AAE metric, and then we look at how good that AAE metric has been historically. We determine what is typically pretty good for that loop, and that gets assigned. They can be adjusted and tightened based off of thresholds for it. But that's going to be kind of the time and control, which is how well are you operating within AAE, as well as the output travel metric, which is how much your output travel is moving around. Is it within a certain tolerable amount? And some of the more details behind that are in the position paper and some of the back end information that we could probably spend another hour talking about limits and thresholds and so forth. But yeah, it's AAE, and output travel is the time and control.
Okay, thanks a lot, Bob and George. So just to finish here, here's our specialist. So you can read the QR code that goes directly to our contact page in our website. There is their emails as well. So if you have any question and comments, want to talk with us, just send an email. And don't miss our next webinar happening on November 12th. We will be talking about mastering PID control, the top 5 factors for optimal loop tuning with Dr. Bob Rice and Damien Moreau. And thank you all for coming here today. I wish you all a great week.
Thanks, everyone.
Thank you, everyone.